Thank you. So my talk is great tables for everybody because I'm talking about the package great tables. Incidentally, I've got 3 goals for this talk. Make you like tables by the end of the talk, especially great tables, the package, the tables you make from great tables, and convince you of their goodness in science. We can use like great tables for science. We're at SciPy after all, so I want to show you some examples of that. Okay, let's start. Why do we make great tables? We did it to enable the building of tables, obviously, but it's also focused purely on the display of tables. If you ever had to share a table with somebody, you want to make it look good. You want to make it presentable. So that's the whole idea here. So again, this is not the only approach to table making in Python, but what we have is something that's comprehensive, it's actively developed, and it's really great for sciencey tables, as you'll soon see. Okay. And then there's a bit of confusion with tables, right? What are we talking about, really? We can give them other sort of like alternate names, like display tables, summary tables, presentation tables. These are just kind of like tables you want to show to people that don't look terrible. That's the idea. So what I want to see in the world is like less of the stuff on the left, which is basically just a data frame printout in a console, and more of the table on the right, which looks super nice. It has a title. It has like nicely formatted, pretty much everything. So that's the world I want to live in. So how do we make tables today? Okay, so we could do this. Raw data frame, give it to somebody. Maybe it's fine. Probably it isn't. I don't recommend it. I wouldn't do it because you can't even see all the data, for one thing. And it looks kind of like not so great. Okay, another idea. This is something I'm guilty of. Take your data, dump it to a CSV, and then bring it to Excel, make your table there, and then bring it back to wherever you need to bring it back to. That's okay. But the problem is your reproducible workflow, if you wanted one, is now broken. So terrible. Don't like it. What I'm recommending, the whole purpose of this talk, is to use great tables, make really great tables entirely in Python. So it's reproducible, probably less effort once you learn how to use great tables. And the tables, they look good. I'll show you more good-looking tables soon. So what I like about this table, this is a table made from a data set in the package SCA. And if you just zoom in a little bit, you see like nicely formatted values, good alignment for excellent readability. And also we have like a heat map in this table, which is super cool. It allows you to just scan around the table, not having to look at the values so precisely, but just you can sort of get like the idea of how the data is in the table. So let me tell you a bit about how great tables thinks of a table, how it structures a table. It's basically done with components. So here's the most basic form of a GT table. It just got column labels, a table body, pretty bog simple. But we have this other feature called a stub. It's a little thing that goes to the left. It's essentially another column, but it's kind of set off. It's nice. You can put row labels in there, and in the top left, you can put a label on top of all these labels. So it's not always needed, but it's actually quite useful. Now, another thing you can do to add structure to a table is bundle your rows into groups, and those groups can have labels themselves. Nice way to sort of like structure your data. We also let you put in a title and a subtitle in the table header. It's great for describing what the table really is. And at the bottom, we can have additional notes in the table footer. You can have source notes, but you can use them for whatever. So additional information about the table. And another way to structure data is you can structure your columns as well. Use spanners for that. We see this all the time in tables printed in, say, journals, for instance. So we call those spanner labels. You can have unlimited levels of those above the column labels. So yeah, that's how Great Tables looks at a table, and this is used all throughout the API. Okay, so when you make a table with Great Tables, here's a sort of prototypical workflow. You have your table data. So what you want to do is you want to put your data into a form that's reasonably close to like the actual output of the table. So we can use like all sorts of tools like polars and pandas. In this talk, I'll be using mostly polars. And then we have our GT object. So that's basically, that's great. That's when you can add all sorts of stuff. Just use the API, make a great looking table. And you can preview this table inside the notebook. You can sort of iteratively create the table, which is nice. And once you have the table, it looks satisfying to you. You can output it to HTML, save as an image. You can have types to output via Quarto, if you heard of that. And you can use these tables wherever HTML is accepted, essentially, like web apps, notebooks, etc. So we have a lot of data sets inside of Great Tables. They're great for making examples, and they're just great to have. So we have 16 of them, which is a lot. But they're useful because today I'm going to show you 3 tables using 3 different data sets. And because we're making the tables from code, we're benefiting from the reproducible workflow. So a bit of a spoiler, these are the tables I'm going to make. It's kind of good to show you what we're going to end up with. So 3 data sets, 3 great-looking tables made with great tables. Okay, I'm going to start with the reactions data set. And here's the final look at the table. And I'm going to show you just some of the features that I want inside the table. So a title, that's what I want. A column spanner, that's going to span across 3 columns. And then nice column labels. What I mean by nice is not like the original labels from the data frame itself. You know, sort of dressed up column labels. And then format. We're going to format the values so they're in scientific notation. Pretty cool. And then stylistically, we're going to change the font from the default font. And we're going to apply a table theme so it looks sort of like all dressed up. Okay, so what I'm going to show you lots of code in this talk for the 3 different tables. This is some Polars code, and we don't have to look really closely at this. But one takeaway is, one good thing is we use Polars selectors here, and also within the Great Tables API, because it allows you to select columns with these simple selectors like starts with, ends with, things like that. So we're going to import that, and that's useful in Great Tables. So the first thing we do is use the GT class, and now we have our HTML table. Very nice. We have a stub as well. Then we're going to add a title. So we do that with tab header. That's the method. So it's just a bunch of methods is what we're using, and then very simple arguments to build up the table. So there's the title. Next, we're going to add a spanner label above 4 columns. And see here we're using in columns PS ends with. We're using some Polars inside of our Great Tables API, which is super cool. And a really cool thing here for science is that between these curly braces, we have a special notation for defining units. So it's nice. You can just use ASCII and define things which are, otherwise a little bit difficult to define, like superscripts, essentially. Okay, and another thing we do is we're going to format some values. We can format compounds, like chemical formulas. They look really nice. But format units. And all those values in scientific notation would format scientific. And then there's missing values. There was a bunch of nuns in the table. Doesn't look really great for presentation, so we're going to substitute that with just m dashes with sub missing. And then finally, we had a column which had nothing but missing values. That's pretty, not really useful. So we're going to hide that column from display with calls hide. Okay, then we're changing our column labels. I recommend doing this every single time. Just changing your column labels from the default to something nice. So that's what we did there. And then finally, we're using opt stylize to apply a theme. Okay, not finally. We're doing one more thing. We're changing the padding horizontally, so there's more gutter space between the different columns, so it presents better. Okay, last thing I swear. We're changing the default font to a different font using a stack, which just means a theme, a font theme, essentially. Okay, here's our table. Looks better than the original data frame. I would present this somewhere. So this is a much better thing than just like the raw data frame. Okay, so I'm going to take a little segue here. I'm going to talk about formatting methods. We have lots of them. I just want to show you a few examples of how they're used, which methods we have. Here's an unformatted column. If you were to use format number, we can get things like right off the bat, grouping separators and fixed decimal places. And that's without using any options. If you just want integers, you can use format integer. If you want scientific values, just like you've seen, format scientific is your friend. If you want percentage values, you can use format percent. Currency values. Great Tables knows all about currencies. You just give it a currency code. It knows what symbol to use and how many decimal places past, like the decimal mark. Really awesome. Just some specialized ones like format bytes in case you need it. And each of these methods has an argument called pattern. It lets you decorate the formatted values with any sort of literal text around those formatted values. Okay, we got many more of those. I'm not showing you those, but we have more in development. Formatters are really cool. That's why we want to sort of have it as a temple feature of Great Tables. Okay, data set number 2, example number 2, using the nuclides data set. So here's my Polars code just to get a huge table into a table that's only 14 rows and 4 columns. I won't go through this, obviously, but there's the code. This works. So we use GT. That's how you start off any sort of Great Tables table, and we have this table. So we're off to a good start. Adding a title, as before, very useful in tables. This is adding a stub head label in the top left, so we're just adding isotope. And then we're formatting number values and also some values in scientific notation. So you have a few arguments there, and you can actually scale values and choose a number of decimal places. And we have missing values, but in this case, we're going to do a targeted selection of 2 columns with 2 submissing calls. It's only because we want the replacement value to be a little bit different in each one. Okay, finally, we have another method called data color. In this case, we have categoricals down that column decay_1, and all it does is sort of like use those colors in the palette, and the first seen value just gets that color, and so forth. Finally, we're using calls label to make the labels look presentable, and we're actually doing a little bit of alignment so that that decay1 column is center aligned, because I think it looks better. Okay. Finally, we're doing some final tweaks with the opt methods. We're changing the alignment of the table header to the left, and we're also changing the vertical padding so the table is not so tall, but a little bit scrunched up. There's our table. Looks really, really good. I would present this. Okay. Another segue, I'm going to talk about another method, data color. Heat maps and tables. This is a table made with gray tables, and the cool thing about it is it has a heat map, care of data color. So we colorize data by value, and the cool thing about that is we get to emphasize differences in values. It's nice. And we get to reveal some trends in the data just from doing that. So if you look at one row, you can compare across measures without even looking at the values. You just look at the sort of color. And same with columns. You just look up and down. You can sort of get a sense of what the scale is just from the colors changing. Okay, finally, third data set, third example, Gibraltar. Anybody ever visited Gibraltar? One person. Whoa, nice. Okay, very cool. So basically, this is the weather data set. And what I've done is I used some Polars code, probably pretty poorly, but I did my best. And what I've done is I made list columns with temperature and humidity. Because the idea there is I want to show a lot of basically all the temperature data per day. So I've got an aggregate of every day. There's some temperature data, there's some humidity data, and we're going to make a table of this. Okay, this looks bad, but it's going to get better, trust me. So I added a header with a title and a subtitle this time. And you might see that, the list columns, they look fully printed out. It's going to look better. Because what I'm doing is I'm going to use a method called format nanoplot. And what it does is it actually makes little plots inside of your table. And these are really nice, fun plots that you can customize. And they pack a lot of data into a table. And they fit nicely inside the table cells. They're very customizable. So what we've done here is we've used the nanoplot options helper and sort of save that to nano ops. That's what you see on the right. It just means that we can customize these individually. Okay, and then one final thing I'm going to do for formatting is format the dates so they look kind of nice. We're using a format date to do that. And it has a bunch of keywords where you can just really simply, from some presets, format the date. But no muss, no fuss, that sort of thing. Calls label, we're doing a cool thing where we actually make it so you get degrees Celsius there with a little bit of curly brace code because we can get symbols from that. Otherwise, it's a little bit hard to do. And there's our table. So a lot of data in a table, and it's a really great summary of weather. Okay, third and final segue about a method. This one's format nanoplot. Nanoplots were actually inspired by sparklines, which you may have heard of. They were popularized by Tufte in his writings. And there's an implementation, of course, in Excel. And people really love that feature a lot. And so it seemed like a cool thing to do to add to gray tables. So here's another table using a data set that's actually in gray tables and basically has nanoplots in it. And the cool thing about nanoplots is that you can see right away for this patient, the white blood cell count increased beyond the normal range. And that's super important. If you just had numbers, the time to that insight would probably be a little bit lower. So this is really good to have. And it's also really cool because you can actually interactively inspect exact values. So features of tables, like having precise formatted values, are there inside nanoplots. You just have to hover over the values. So that's really super, super cool and actually kind of fun. And did I mention that these are all super customizable? You can have bars. You can have just lines like this. It's really quite nice. Okay, and nanoplots, of course, you can probably think of a million ways to use them. Here's just 3 more examples: stock prices, weather data, not too dissimilar from what you've already seen, and some sales data based on pizza sales. Okay, summing up, you can make really nice beautiful, I'd say. Publication quality tables with great tables. I think tables are cool. I really feel they're going to get their day one day. And I know that people love good-looking ones. Like when I see a table with data I care about, I'll pore over that table for quite a while. It's really amazing. And you don't have to compromise on reproducibility when you use great tables. You can basically use great tables in the visualization step. You don't have to dump out your data. You can just use it all in one go. And your reports and such will probably be greatly improved because of that. So to get started with great tables, it's on PyPI, so you can just pip install great tables. And there's a great project website we have at PositDev. I'm from Posit, by the way. PositDev and on GitHub, great tables. Just search it up. We have tons of examples there in the examples gallery. And we have a blog as well, which has a few articles, even some new ones. OK, thank you so much.
Thank you, Richard.
Yeah.
Do you have questions?
I think in your first example, you showed some code where you could use various ASCII characters to modify the formatting of some labels, like subscripts, superscripts, that kind of stuff.
Yeah.
Do you also support inserting like LaTeX for equations and Greek characters?
We have Greek characters actually within that type of formatting. LaTeX equations, that's coming soon, or later, I should say. And LaTeX as an output, like format for tables, is also forthcoming as well. So right now you have like, if you learn to use like that sort of like shorthand, you can actually insert symbols with surrounding a keyword with colons. Yeah, there's quite a range of like the usual symbols you would expect in units. Yeah.
Any other questions?
Does any of this work in the terminal?
Yes, you can run it in the terminal, and we now have a show method, so it'll actually emit the table into a browser. Yeah, so you won't just get the object printed out. Like it'll.
Sorry, what I mean is, can you render any of this fancy stuff? Like
Oh, I see,
in
like
the
terminal rendering.
directly?
Yeah, no, like Rich does that. Like the Rich package is like adept at that sort of thing. We don't really have that. We might have that in the future if there's sort of lots of demand for it, but right now. Oh, I didn't know. Okay, maybe I'll do it.
Any other questions?
I was curious about the nanoplot function. Are you using another library to handle that, or did you write your own plotting handler?
I just did it myself. Basically, it's SVG creation. So essentially, yeah, it's all code that's within Great Tables. We may strip that out and make a separate library because it feels kind of strange that it's just like trapped inside there. It's broadly useful. But right now, it's just like our own sort of code. Yeah.
Cool. Thanks. Great talk. I'm curious about the use of polar selectors. Does that work for pandas inputs as well, or is that polar selectors work on polar inputs?
Yeah, you can have, of course, this can ingest pandas data frames, but polar selectors do not work with pandas. Essentially, we have this is before narwhals came out. We sort of made our own abstract backend. And so we accept some things, only Polar's data frames will accept Polar's sort of like API stuff. And pandas, you'd have to use like a Lambda or just the column names, or go without, essentially.
Okay, it makes sense. I was just curious.
Yeah.
I'll come to you in a second. We had an online question as well. They were asking, since you had a lot of colors shown in your tables and such, do you have colorblind friendly palettes?
Yeah, in data color, we do have a bunch of keywords that allow you to select palettes, and we have a few colorblind ones from Viridis, or Cividis, I should say, which is a branch of Viridis.
Oh, sure.
Yeah. Oh, nice.
Any other questions? Yeah.
So you mentioned that you generate HTML. I'm curious, with the nanoplots, are you including the data as well in that HTML plot? Or are you like, does that make sense? Is it like base 64 encoded and you render it, or you like create some line in advance, or how are you?
Essentially, it's all HTML. There's pure HTML, and that's it. But there's no base 64 encoded stuff in there at all.
Yeah, I guess what I'm wondering is, for that plot, is the data from that plot still somehow in there so that that plot shows up correctly, or how is it?
Oh, the plot is an SVG, which is
Okay.
totally accept. Yeah, just a tag inside
Got
the
it.
cell. Yeah, that's how it works. Yeah.
Thank-
Yeah, you're welcome.
All right, well, it looks like there's no further questions. So thank Richard once again, and you guys can go out to your next thing.
Thanks.